The ESA released images of the Three-Eye Atlas, while NASA remained silent. What they show breaks all the rules we know about comets. Scientists cannot explain. At this very moment, a 33 billion-ton object is passing through our solar system at 215,000 kilometers per hour. And it is not from here. The gas orbiter. The ESA's ExoMars trace detected negative polarization reaching 2.77%, something never observed in any comet. The equipment was not even designed for this type of observation. The object appeared between 10,000 and 100,000 times fainter than typical targets, yet they managed to capture it. Perfect timing, as Mars, Venus, and Jupiter aligned for ideal viewing. The probability of this alignment? Less than 1%. This massive visitor aligned within 4.89 degrees of Earth's orbital plane. Statistical analyses show less than 1% chance of this happening randomly. Harvard scientists discovered that the brightness profile does not match any known comet in our databases. Even more disturbing, its direction of arrival aligns within 9 degrees of where the famous WOW signal originated in 1977. 3. I-Atlas broke all the rules we thought governed interstellar objects. Here is what should scare you more. While NASA was in the dark during the passage by Mars, ESA captured images showing dust grains fundamentally different from anything in our solar system. Think about that. Let's talk about mass. 33 billion tons. To put it in perspective, that is 330 times heavier than Oumuamua, the first confirmed interstellar object. We are comparing a pickup truck to a nuclear aircraft carrier. Just the core measures between 5 and 8 kilometers in width, not counting the surrounding gas cloud. For an object of this magnitude passing through our solar system, the chances are astronomically small. Based on what we know about the density of rocky material in interstellar space, we should not be seeing this. Professor Avi Loeb from Harvard analyzed the data intensively. His team discovered something impossible. The object shows almost no gravitational wobble, despite actively releasing gas visible millions of kilometers away. Using data from 227 observatories around the world, researchers tracked small trajectory deviations caused by the release of gases. The acceleration was surprisingly small, less than 15 meters per day. For an object with a visible gas cloud extending for hundreds of kilometers, this minimal thrust means one thing: the mass calculations do not make sense with the natural behavior of comets. Here's the problem. When sunlight reflects off typical comet dust, it creates predictable patterns of light polarization. The light waves align in specific ways after reflection. Three-Eye Atlas is breaking all these rules. Its extreme negative polarization of 2.77% suggests fundamentally different dust grains, possibly rougher, more irregular, or composed of materials we have never encountered before. Nick Thomas, principal investigator of the CASIS camera, admitted that this was an incredibly challenging observation. The camera was built to photograph Mars from a few hundred kilometers away. Even so, they captured an object 10,000 to 100,000 times fainter than the intended targets. But the mysteries do not stop there. The Spheric Space Observatory detected carbon dioxide extending for at least 347,000 kilometers from the core. This is almost the distance from Earth to the Moon. Although carbon dioxide is common in comets, the distribution pattern around the Three-Eye Atlas does not match anything we have seen before. The gas seems to be emerging in specific jets rather than uniformly. This suggests either an irregular surface or possibly artificial venting points. Natural comets do not behave this way. The visible brightness extends about 1,100 kilometers from the nucleus in the latest images from the ESA. But here is the strange part. When Hubble detected the same glow, it extended for 6,400 kilometers. The object was much farther away then. This shrunken appearance is not because the comet is getting smaller. The Cassie's camera can only detect the brightest and densest part of the gas cloud. But the rate of shrinkage does not match our models of natural sublimation. Here is where it gets strange. The Mars Express spacecraft from the European Space Agency attempted spectral analysis, the chemical fingerprint of the object. The Omega and SPICAM spectrometers detected unusual proportions of elements. Preliminary reports suggested nickel without iron. This is an almost impossible natural combination. Scientists are being cautious about confirming this until more data arrives. But if it holds true, we are looking at a chemistry that should not exist in naturally formed objects. Dr. Suzanne Ferner proposed a theory that objects like 3E Atlas could be planetary seeds. Her simulations show that if a large interstellar object enters the gas and dust disk of a young solar system, it could serve as a ready core for planetary formation. Instead of taking millions of years growing from tiny dust grains, a planet could quickly form around this alien seed. If true, some planets in our galaxy, possibly even in our own solar system, may have cores that originated around other stars. And then something impossible happened. Trajectory analysis reveals the most intriguing anomaly. The path of this object aligned with the ecliptic plane of our solar system within 4.89 degrees. All the planets orbit in this flat disk. For a random interstellar visitor, this alignment has less than a 1% probability. The timing seems almost orchestrated. It passed by Mars when the red planet was perfectly positioned for observation. It will pass by Venus at an ideal angle. It reaches perihelion, the closest point to the Sun, just when Jupiter provides gravitational assistance for any potential follow-up trajectory. These alignments would be remarkable for a targeted mission. For a random visitor from interstellar space, they are almost impossibly fortunate. Sintarite ke e atia. The object is currently racing towards the Sun at 215,000 kilometers per hour and accelerating. It will reach perihelion on the 30th of October 2025, passing approximately 96 million kilometers from our star. This is closer than Venus orbits. The intense heat and radiation should cause dramatic changes. Scientists are watching to see if this causes fragmentation or dramatically increased gas release. If neither happens, we have another anomaly to explain. But there is another problem. NASA's involvement has been frustratingly limited. A government shutdown coincided perfectly with the passage by Mars, while the Perseverance rover captured what appears to be 3 and Atlas, like a trail across the Martian sky on the 2nd of October. Detailed analyses from the Mars Reconnaissance Orbiter remain unavailable. The MRO has the high-rise camera capable of 9-meter resolution at this distance. The data exists, it is simply not being released. As Professor Loeb pointed out, having NASA's public data streams go dark precisely during an interstellar passage seems remarkably convenient. The ESA filled the gap with unprecedented transparency. They released raw images immediately. Citizen scientists downloaded and processed data before the official releases. The contrast between the agencies could not be more striking. The data revealed something no one expected. The visible coma around the 3I Atlas shows a diffuse ball of light behaving differently from any comet we have ever seen. The object is losing mass. We see a cloud of gas resulting from heating as it approaches the sun, but the rate of mass loss does not match the level of visible activity. In our solar system, comets originate from two main regions, the Kuiper Belt beyond Neptune and the Oort cloud at the extreme edge of our sun's influence. These regions are cold enough for ice to remain stable for billions of years. 3I Atlas likely formed around a completely different star, possibly in conditions we cannot fully replicate or understand. Its chemical composition suggests formation temperatures and pressures outside our models. The European Space Agency has positioned multiple resources for continuous observation. The Mars Express orbiters and ExoMars will track the object for as long as possible. The JUICE Jupiter mission, Icy Moons Explorer, currently on its way to Jupiter, will attempt observations from a different angle. However, communication delays mean we will not receive much of this data until early 2026. The crucial passage by perihelion on October 30th will happen largely unobserved by our most powerful instruments. The James Webb Space Telescope has allocated emergency observation time. Results will not be public until after peer review. This may take months. By then, 3I Atlas will be returning to interstellar space. We are not saying that 3I Atlas is definitely artificial. The scientific consensus still leans towards natural origins, but we have reached a point where even conservative scientists are asking uncomfortable questions. If objects like 3I Atlas are more common than we thought, this suggests that interstellar space is full of massive bodies that we have simply missed until now. Our detection methods need a complete overhaul. If they are as rare as statistics suggest they should be, then we need to explain why we are lucky enough to see 3 interstellar objects in just 8 years. Oumuamua in 2017, 2I Borisov in 2019, and now 3I Atlas in 2025. The chances of this detection rate, given our current research capabilities, are less than 1 in 10,000. Either we are experiencing an unprecedented statistical anomaly or something else is happening. The implications go beyond an unusual comet. Every telescope capable of tracking 3I Atlas is doing so. This creates the most comprehensive observation campaign of an interstellar object in history. We are collecting data at an unprecedented rate. But here is what should concern you. The timing, the trajectory, the alignments, the chemical anomalies, the mass inconsistencies, the unusual polarization. Taken individually, each one may be explainable. Combined, they paint a picture that does not fit our understanding of natural objects. NASA's silence during the crucial passage adds another layer of mystery. While the ESA released images showing comet behavior never seen before, NASA's Martian resources capture data that remains classified or undisclosed. The contrast raises questions. What did those high-resolution images really show? Why the convenient timing of the shutdown? Why weren't the data released now that operations have resumed? The next few weeks are critical. As 3I Atlas approaches the sun, any changes in its behavior, structure, or composition will provide crucial clues. If it survives the perihelion intact without the expected fragmentation or dramatic gas release, we have another impossible data point to explain.
If it fragments, the pieces will reveal internal structure.
Natural comets show predictable fragmentation patterns. Anything else would be significant. What happens after the perihelion could revolutionize our understanding. The object will pass within the observable range of several major ground-based observatories. Each will capture data from different angles, creating a three-dimensional image of its structure and composition. But time is running out. Syria Ayatollahs is moving fast. After perihelion, it will head back to interstellar space. In months, it will be too far for detailed observation. In a year, it will be beyond detection by anything except our most powerful radio telescopes. This may be our only chance to study such a large and active interstellar visitor. The data we collect now will either confirm our theories about comet formation and decomposition of interstellar objects, or force us to completely rewrite these theories. The scientific community is divided. Most researchers favor natural explanations, citing the complexity of comet behavior and the limitations of our current models. A small but growing minority suggests that we need to consider alternatives. As Professor Loeb stated, we must follow the evidence wherever it leads, even if it takes us to uncomfortable places. Extreme polarization, massive size, perfect alignments, unusual chemistry, and minimal gravitational response to gas release point to something we do not fully understand. We have a confirmed fact. 3I Ayatollahs is here. It's massive, it's behaving strangely, and we are observing it in real time. Everything else is hypothesis, theory, and careful analysis of incomplete data. The universe has just handed us a puzzle wrapped in mystery, flying through our solar system at visible speed. In days, it will reach its closest approach to the sun. Whatever happens next will either confirm our understanding of interstellar visitors or challenge everything we thought we knew. The images from the European Space Agency, released on the 7th of October 2025, show a diffuse ball of light that should not exist. According to current models of comets, the negative polarization reaches values that force scientists to rewrite their calculations. The mass suggests something that statistically should not be passing through our neighborhood, and NASA remained silent during the most critical observation window. Think about it. If this story captivated you as much as it did us, make sure you hit that like button and subscribe to this channel. Estamos rastreando o 3I Ayatollahs em tempo real, e você não vai querer perder o que acontece durante o periélio em 30 de outubro. Deixe um comentário com sua teoria. Isso é totalmente natural ou estamos vendo algo que redefinirá nosso entendimento sobre objetos interestelares? E compartilhe este vídeo com quem acha que entende de cometas. Depois disso, eles nunca mais pensarão assim.